How's it going, guys? Today I'm going to show you how to solve this problem using a min heap. And don't worry, it's not going to be too bad because of a slightly confusing thing about this problem. We're not actually going to have to create the heap from scratch. In this problem, we can use this min heap priority queue package right here. It's actually imported into LeetCode, which isn't, it's not told to us anywhere. So I was really confused by this, but it works. So let's talk about the problem really quick. There's two parts to this problem: creating the class, initializing it, and creating a function which adds to the class and returns the kth largest element in the stream. So basically, this input over here is a little confusing. The first thing that happens is it initializes the class with these, k is 3 and nums is this. Then we call the add function with 3, add with 5, add with 10, and so on and so forth. All right, so what does this actually mean? The kth largest element in the sorted order. So basically, we just need to sort nums and then return the kth largest element in nums. So that brings us to min heaps. And we're going to use min heaps here because we can make a heap for the length of k and then just return the root of our heap. And that will give us the kth largest element. And if you haven't coded classes in JavaScript before, please take a note of this because we can actually create classes three different ways in JavaScript. This was confusing for me. This is the class way where you just call the class keyword and name your class kth largest. And inside of the constructor, we basically have to initialize this class like this: object equals new kth largest, and we pass in these two parameters from our constructor, k and nums. And in the first example, k is 3 and nums is this array. So that's how it's created. Nums is then passed to this dot min heap is what we're calling the min priority queue, which again is a function that is part of this library, okay? So we're going to create our min heap using that library, and then we're just going to pass it the nums from our nums array and add them to the min priority queue. And when we do that, it's automatically going to sort the nums and create a binary search tree for us with the smallest value being the root. And then all we do is we add in a function to it called add. That takes an add value, or a value as its parameter, and it calls the enqueue function, which again is part of this library. And that will just essentially insert this value at log of n time, which is great. And then what we're doing here, this is the logic where we're reducing the size of our min heap to the size of k, which means our root or the front um, element will be the kth largest in the entire heap. The other syntax for creating a class is a little bit confusing because it looks like a regular function, but pay attention to this capital K. It's Pascal case instead of camel case, where this K would usually be lowercase, and then we're using this keyword inside of it. So this is actually a constructor in both of these. It's actually a constructor. So you actually have to create a class in the same way. You'd have to call a variable object equals new kth largest. And there's two different ways you can add the function to it. This way is not recommended. It's actually creating a property on each instance of the class, kth largest. Whereas by adding it to the prototype, it's sharing the method add. So it's only using um, space and memory for one add function, and it's sharing it between the two. So don't do it like this. If you're going to use this syntax, use the prototype. So kth largest dot prototype and then the method's name, and then write the method in it. Let's step through our algorithm. The first thing we do is initialize our kth largest class. In the first example, k is 3 and nums is this array. So we use those and we create a object or obj and set that equal to a new kth largest class. And here are our k and nums. So as we create this class, we're actually calling the add function. So we don't actually put all of these nums into our min heap. What happens is we call our add. So when we get our full array into the min heap, it's going to check the size and see that, oh, wait a second, it's larger than k, size is 4 and k is 3, so we need to remove this root. We call the dequeue on the root, which is this front, and that basically takes it and chops it off and returns this front node. Step 2, calling the add function. Because of the way our min heap is initialized in kth largest class, we always call add, which means our min heap will always be the size of k at this point. So when we go to add 3 in this first example, we're never going to get to this. We're going to add 3 and it's going to go through the add function. It's going to add it here. But what happens next is it compares the size to k. So size is 4, k is 3. Uh-oh, we need to chop off this root, which is our front here. We chop it off, we get this, and we just return our new front or root, which is 4. Let's do one more example. So our min heap now looks like this, 4, 5, 8, okay? And we want to add 5 this time. So we're going to call add on it for 5. And the same thing happens. We pass in the val of 5, which gets passed to enqueue 5, and we add 5 to our min heap, and it's sorted in log of n time. The size of our min heap now is 4, and we need to make it 3. So we shift off the 4, which looks like this. 4 gets deleted. We shift up for our 5, and now 5 is our new root or front, and we just return 5. That's all.